we have studied first three reaction intermediates in detail. One carbocation, second carbanion, and third one is the free radical. मग त्याचं डिस्कशन करत असताना we have studied in 5 steps. One is the introduction. यामध्ये आपण काय पाहतो? What is the definition? What are the examples? त्यानंतर second point यामध्ये structure. Then also about the generation, means how that intermediates are generated during organic reaction. त्यानंतर पुढचा यामधला stability. Okay, we have studied comparative stability among that reaction intermediates. What is the role of resonance effect, inductive effect, hyperconjugation effect on the stability of free radical, on the stability of carbocation, and on the stability of carbanion. We have studied that stability also. This is very important point. And also we have studied reactivity. Last step मध्ये आपण त्याची reactivity study करतोय. Means we have studied some examples of organic reactions which involve formation of that intermediate. Okay, now let us see next reaction intermediate, carbene. Okay, let us see example of carbene first. I will take a simple example. Okay, this is CH2 carbon having two covalent bond with hydrogen, and there is a electron pair. There is a lone pair of electron on the carbon. Here also, suppose that carbon having two chlorine, and there is electron pair, non-bonded electron pair, and these are the examples of carbene. Okay, suppose we can show that carbene by structure carbon having two covalent bond with the chlorine, same species actually, while there is an electron pair on the carbon. Okay, this is just a carbene. That intermediate is called carbene. Now, what is the characteristic property of the carbene? What is the characteristic property? In carbene, carbon having two covalent bond. In carbene, carbon having two covalent bond, and also it do not having any charge. Therefore, simply we can say that carbene is a divalent and neutral carbon species. It is divalent, means it having two covalent bond, then it do not having any charge, and thus it is divalent neutral carbon species. Okay, this is the first point. Now let us see second point. यामध्ये आणखीन एक point कोणता आहे? How many electrons are there in the valence shell of central carbon? Suppose this is the carbene, this is central carbon, then this bond having one electron pair, means two electrons, then second bond also having two electrons, total 4. Then also there is a lone pair of electron, non-bonded electron pair, it also having two electrons. Thus totally there are 6 electrons in its valence shell. Okay, this is the second point. We can say that it having 6 electrons in its valence shell. Okay, we are having two main properties regarding carbene. पहिली property काय सांगितलं? It is divalent neutral carbon species, and second, it having 6 electrons in its valence shell. And we can define it also. The divalent neutral carbon species, the divalent neutral carbon species which having 6 electrons in its valence shell is called carbene. Okay, this is the example of carbene. Okay, now let us see some more discussion. Is it electron deficient or electron rich species? Actually, there is a lone pair of electron on the carbon. Even though there is a lone pair of electron, it is not electron rich species. It is electron deficient species because there are only 6 electrons in its valence shell. Means it having 2 electrons less to complete its octet. According to the octet theory, atom should have 8 electrons in its valence shell. Then it becomes stable. But here, that carbon having only 6 electrons in its valence shell. Therefore, there is a deficiency of electron. Okay, it is electron deficient species. And therefore, simply we can say that, yes, it is electron deficient. Okay, so it is electron deficient. Therefore, in chemical reaction, it acts as an electrophile. We know that all the species which having positive charge, which having electron deficiency, these are electrophile. And here also in chemical reaction, it acts as an electrophile. Okay, thus carbene is an example of electrophile, not nucleophile. It is an electrophile. Okay, this is just about the introduction. We have studied some examples. What is the definition? And main 2 points regarding the carbene. It is electron deficient and act as an electrophile. Let us see next point, just about the structure of carbene. Okay, let us see structure of carbene. Now, carbene can be exist in 3 different forms. It exists in 3 different forms. One is a sp2 singlet carbene. This is the first form. Then second one is the sp2 triplet carbene, and third one is the sp triplet carbene. These are the three forms regarding the carbene. We will see in short all the three forms of carbene. First about the sp2 singlet carbene. Okay. Now here in sp2 singlet carbene, the hybridization of central carbon is a sp2. Hybridization of central carbon is a sp2. Now we know that actually how the hybridization of carbon occurs. One s orbital and a 2p orbital, they undergo mixing and recasting, and there is a formation of three new orbitals, and this is called sp2 hybridization. Means there are three sp2 hybrid orbitals. Now here what happens? This carbon form two covalent bond. The sp2 hybrid orbital overlaps axially to form two covalent bond, while there is one more sp2 hybrid orbital. Okay, this is also sp2 hybrid orbital, but it do not participate in bond formation. It do not involve in the bond formation. While that carbon also having unhybridized orbital, and this is the 2p orbital of carbon, and it lies perpendicular to the main plane. We know that in carbene there are two non-bonded electrons, and these two electrons are present in sp2 hybrid orbital. In singlet carbene, in sp2 singlet carbene, that non-bonded electrons are present in sp2 hybrid orbital, while these electrons are paired with opposite spin, and bond angle is near about 100 to 110 degree. Okay, this is about sp2 singlet carbene. sp2 singlet carbene मध्ये कोणते महत्त्वाचे पॉइंट्स आहेत? पहिल्यांदा हायब्रिडायझेशन ऑफ कार्बन इज sp2. Okay, then two sp2 hybrid orbital form two covalent bond. Okay, then there is a unhybridized 2p orbital which lies perpendicular to main plane. त्यानंतर पुढचा पॉइंट, the lone pair of electron, non-bonded electron are present in one sp2 hybrid orbital, and here that electrons are paired with opposite spin. Now let us say about the second. यामधला second जो आहे त्याबद्दल आपण बघूया, sp2 triplet carbene. Okay, here also in that triplet carbene, central carbon having sp2 hybridization, and here two hybrid orbital form two covalent bond, while third hybrid orbital is like that. Okay, this is the third sp2 hybrid orbital. Now this carbon also having 2p orbital, unhybridized orbital, and it lies perpendicular to that plane. याकडे असणारे जे लोन पेअर्स ऑफ इलेक्ट्रॉन आहेत किंवा दोन इलेक्ट्रॉन्स आहेत, टू नॉन बॉन्डेड इलेक्ट्रॉन, here one electron is present in that hybrid orbital, while second electron is present in the 2p orbital. Okay, and thus the two electrons are present in a different orbital. यामधला एक असेल हायब्रिड ऑर्बिटल मध्ये आणि एक असेल 2p ऑर्बिटल मध्ये, and these two electrons are unpaired. The two electrons are unpaired and they are having parallel spin. This is the characteristic property of sp2 triplet carbene. The two electrons are unpaired and having parallel spin, while bond angle is near about 130 to 150 degree. This is about the sp2 triplet carbene. Okay, now there is one more form, and this is nothing but the sp triplet carbene. ठीक आहे, या तिसऱ्या फॉर्म बद्दल सुद्धा आपण बघूया. ओके, दिस इज अवर सेंट्रल कार्बन. नाउ इन दिस केस हायब्रिडायझेशन इज अ sp, one s orbital and one p orbital, they mix up and recast, and there is a formation of two hybrid orbital. This is called sp hybridization, and they form two covalent bonds. Now this carbon having two unhybridized orbital. Okay, this is first unhybridized orbital, 2p orbital म्हणूया त्याला आपण. This is second one. Okay, they are lies perpendicular to that main plane. मुख्य प्रतलाला ते perpendicular असतील 1 and 2. Okay, these are the 2p orbital. त्याकडे असणारे जे non-bonded electrons आहेत, that non-bonded electrons are present in that 2p orbital. Okay, one is present in one 2p orbital, second is present in another 2p orbital, while they are unpaired and they are having parallel spin. ते अगेन हे सुद्धा अनपेअर्ड आहेत आणि त्यांचा स्पिन पॅरलल आहे. दिस इज जस्ट अबाउट द स्ट्रक्चर ऑफ कार्बेन. वी हॅव स्टडीड 3 डिफरंट फॉर्म्स ऑफ कार्बेन. वन इज द sp2 सिंगलेट, सेकंड इज द sp2 ट्रिपलेट अँड थर्ड वन इज sp ट्रिपलेट. लक्षात ठेवा, ट्रिपलेट आहे म्हणजे त्यांचा स्पिन पॅरलल असतो, दे आर अनपेअर्ड. आणि जर सिंगलेट असेल तर दे आर पेअर्ड विथ अपोजिट स्पिन. ओके, दिस इज जस्ट अबाउट द स्ट्रक्चर ऑफ कार्बेन. वी हॅव स्टडीड 3 डिफरंट फॉर्म्स रिगार्डिंग द कार्बेन. Okay, let us see next one. Generation of carbene. How that carbenes are generated during organic reaction. How they are formed during organic reaction. Actually, we will see some of the methods or some of the simple organic reactions in which that carbenes are generated. First method is the from alkyl trihalide. Okay, this is very common method. Suppose this is example of alkyl trihalide. Name of the compound is a chloroform. Okay, CH-Cl3 chloroform, carbon having 3 bonds with the chlorine and 1 with hydrogen. When that chloroform comes in contact with strong base, suppose it is treated with KOH or NaOH. Now here that OH minus, that this base, it takes that hydrogen atom from the alkyl trihalide. या क्लोरोफॉर्म मधला हा हायड्रोजन बेस घेतो, म्हणजेच काय तर OH मायनस आणि इथला H प्लस, म्हणजे कार्बन आणि हायड्रोजनच्या मधला बॉन्ड ब्रेक होतो. दिस इलेक्ट्रॉन पेअर गोज टुवर्ड्स कार्बन. Okay, and there is a loss of H plus ion. Now that H plus ion and that OH minus, there is a formation of water molecule. While this electron pair goes towards that carbon, it acquires negative charge, and there is a formation of negatively charged carbon species, and this is nothing but the carbanion. In first step, there is a formation of carbanion. Now, this carbanion again loses 1 chlorine. यामधून आणखीन काय होतं, या बॉन्डचं ब्रेकिंग होतं. दिस इलेक्ट्रॉन पेअर गोज टुवर्ड्स क्लोरीन आणि इथून काय बाहेर पडतो Cl मायनस. देयर इज अ लॉस ऑफ Cl मायनस. कार्बन हॅव्हिंग 2 क्लोरीन, कार्बन हॅव्हिंग 2 क्लोरीन. आता मी कार्बन वरती इथं काय दाखवलेलं आहे, आय हॅव शोन इलेक्ट्रॉन पेअर, पण मी त्यावरती निगेटिव्ह चार्ज दाखवतोय का, नाही दाखवला. का नाही दाखवला बघा, तर लक्षात ठेवा, हा जो बॉन्ड आहे हा बॉन्ड ब्रेक होत असताना इलेक्ट्रॉन पेअर गोज टुवर्ड्स क्लोरीन, मीन्स इलेक्ट्रॉन कोर पेअर गोज अवे फ्रॉम कार्बन. इट गोज अवे फ्रॉम कार्बन. आणि जर एखादी इलेक्ट्रॉन पेअर दूर जात असेल, दॅट कार्बन शुड बी अक्वायर पॉझिटिव्ह चार्ज. या कार्बनवरती पॉझिटिव्ह चार्ज यायला हवा, बट ऑलरेडी इट हॅव्हिंग निगेटिव्ह चार्ज. अगोदरच त्याच्यावर निगेटिव्ह आहे, मग इथला पॉझिटिव्ह म्हणजे तो न्यूट्रल होतो. अँड देअरफॉर आय डू नॉट शो एनी निगेटिव्ह चार्ज ऑन दॅट कार्बन. पण त्या निगेटिव्ह चार्ज म्हणजे इलेक्ट्रॉनची पेअर आहे, ती इलेक्ट्रॉन पेअर मात्र आपण दाखवतो. इथं जो निगेटिव्ह चार्ज आहे मीन्स इलेक्ट्रॉन पेअर, तो मात्र आपण दाखवतोय, पण चार्ज दाखवत नाहीये, कारण तो या ठिकाणी या प्रोसेसमध्ये न्यूट्रल होतो. And thus there is a formation of neutral carbon species which having 2 covalent bond, having 6 electron in its valence shell, and this is nothing but the carbene. Okay, this is the first simple method how the carbene is generated during the organic process. We have studied the example of alkyl trihalide, example of chloroform actually. Let us see second method from diazo compound. Okay, suppose diazo compound, very simple example, general example of this diazonium salt actually. Now this diazo compound on heating or in presence of light easily undergo decomposition. मग यामध्ये काय होतं बघा, 1 bond undergo breaking, electron pair goes towards that nitrogen, while 1 electron pair goes towards carbon, and there is a formation of such species, and that species is nothing but the carbene with the evolution of nitrogen gas. Okay, त्यानंतर पुढची जी यामध्ये एक्झाम्पल आहे, फक्त मी डायझोमिथेनचं एक्झाम्पल घेतो. सपोज या ठिकाणी डायझो कंपाऊंड मध्ये सिमिलरली सेम टाइप ऑफ रिएक्शन ऑकर्स, म्हणजे इथला इन प्रेझेन्स ऑफ हीट ऑर लाईट किंवा हीटच्या सानिध्यामध्ये या ठिकाणी डिकम्पोजिशन होतं, या बॉन्डचं ब्रेकिंग होतं, अँड देयर इज अ फॉर्मेशन ऑफ कार्बेन as an intermediate with the evolution of nitrogen gas. Okay, this is just a formation of carbene by using diazo compound. Now let us see one more method for the generation by using ketene. Okay, this is called ketene. R C double bond O. That compound is called ketene. Here also, in presence of light or at high temperature, this bond undergo breaking. यातली एक इलेक्ट्रॉन पेअर कार्बन कडे आणि एक इकडे जाईल, and there is a formation of carbon monoxide. इथून CO या ठिकाणी लॉस होतोय, along with the formation of RCr, and that carbon having a non-bonded electron pair, and therefore this is nothing but the carbene with the loss of carbon monoxide. Suppose example Here also this bond undergo breaking in presence of light or high temperature, and we get the carbene. Okay, thus during decomposition of diazomethane, decomposition of ketene also, there is a formation of carbene as an intermediate. Okay, this is very important intermediate formed during organic reaction.